Hello students, welcome to the physics class, Turito foundation classes. We would like to go for this one, 7th class physics. We would like to discuss about that problems based on units and measurements. It's very clear. You would like to go for this, the whole length of the meter scale. Suppose if you are going to take that a meter scale which is having that 100 divisions. Let's assume if we are going to get that 1 meter is going to be the 100 centimeters. It's very clear. We would like to go for that. Suppose it has been divided that 500 equal parts. Okay. Is there any change in the magnitude? It doesn't change. Magnitude does not alter. Even though if you have been divided into that number, whatever it may be. But one thing, one line, if you should make it any number, but one division is going to represent the different value. Initially, you have been taken that 1 meter scale, it is having that 100 divisions, okay, 100 parts. Each line represents 1 centimeter, it's very clear. If you make it 500 equal parts, in the given problem, this is the case. The whole length of a meter scale is divided into 500 equal parts. Okay, whatever it may be, its magnitude doesn't change, but one division represents that one value. Okay, it's very clear. Suppose you can use that. What is the smallest measurement that you can measure by using that scale? Yes, that is going to be having the understanding. Yeah, you have been imagine the total number of lines. Just you have to make it instead of 100, you can make it 500 lines. What is that? One line magnitude, and what is the representation of one line? It will represent the centimeter or millimeter. Just you have to take that. No? That's very clear. So 1 centimeter, just you have to get that. It's very easy for you to solve this problem. Initially just you have to take that meter scale. All right. It is having that 100 divisions. Just you should take that. Just you have to confirm this one. This is going to be 100 divisions. It's very clear. Okay. All right. But if you are going to make it 500 divisions. You can confirm its magnitude is going to be the constant. It's very clear. The smallest measurement that can be measured, if you are going to take that one small thin wire, you can measure that. It is going to be 1 centimeter also. Okay. If you have taken very thin wire, its thickness is going to be in mm. All right. You can go for that. It is in the measurement of mm. It's very clear. 100 divisions, and this is going to be that 500 divisions. What happened? It's going to be 1 meter. Just you have to take that 1 meter scale. All right. So 1 meter is equal to 100 centimeters. All right. So 1 division, it's equal to 1 centimeter. All right, it's very clear. Yes. If you have been make it 500 divisions, 500 divisions is equal to 1 meter. Okay. What about 1 division? Here you would like to get that 1 by 500 meter. It's very clear. Yes, you have to take this one. Here 1 division is equal to, just you have to take that. Here Just you have to take this one. Yeah, you have to take this one. It's very clear. Yeah, here you would like to get that 100 divisions is equal to 1 meter. 1 division is equal to 1 by 100 meter. All right, it's very clear. This is a general case what we are going to use that. Yes, 1 division is equal to 1 by 100 meter. That is going to be 10 to the power of minus 2 meter. That is going to be 1 centimeter. All right, it's very clear. You can go for this one in the general representation. But if you make it in a special consideration, yes, what we have, 1 meter scale is going to be divided into 500 equal parts. Then what is the smallest measurement that can be possible by using this instrument to measure? Yes, you have to take that. Here, very simple. Initially, if you have taken that meter scale, you can measure that the smallest measurement, that is going to be the 1 division, you can get that 1 centimeter. The smallest measurement is going to be the 1 centimeter. It's very clear. But if you make it 500 divisions, what happened? 1 division is going to be splitting into that 5 extra 1 centimeter. Just you have to take. It is going to be into the next level of that centimeter to millimeter. All right, it's very clear. But we have to look into that matter of that answer. Later we will solve that. All right. Okay. It's very clear. Yeah. This is the case we would like to go for that. That implies 1 division is equal to 1 by 5 into 10 to the power of 2 meter. It's very clear. So, it's going to be 0.5, just 0.2 into 10 to the power of minus 2 meter. So, you will get that. Yeah, you will get that. It's very clear. 2 into 10 to the power of minus 3 meter. Yes, if you multiply with, divide with the t, just therefore 2 into 10 to the power of minus 3 meter, does it gives that mm, that is equal to 2 mm. It's very clear, you would like to get that. Yes, you will get that 2 mm. Yeah, for the given question, you have to take this one, 2 mm. Have the look into that matter, all of you please go for this one. That is 2 mm. You know, yeah, if you are going to get that, this is the answer. 2 mm is the answer. If you make it 500 divisions, instead of 100 divisions, if you can make it 500 divisions, so 1 division does it represent 2 mm. Yeah, that is nothing but the smallest measurement. You can get that. Okay, all right, it's very clear. You would like to go for that 2 mm. If you are going to get that next question, just you have to see. A train which is 200 meter long and is moving with a speed of 54 kilometer per hour. All right. The time taken by that train to cross a bridge of 0.4 kilometer. All right, it's very clear. Yes, you have to take this problem. Yeah. Yeah. Length of the train, you have to take that. Of the train, it's very clear. That is going to be 200 meter. All right. Now you can go for that. Speed of the train, you have to consider this one. That is going to be 54 kilometer per hour. Just while you have taken that length, it is going to be in meter. So you can convert that speed in meter per second. It's better for have the calculation. That is 54 into 5 by 18 meter per second. It's very clear. That is 15 meter per second. It's very clear. Okay. length of the bridge, just you have to take that bridge length, yeah, length of the bridge is equal to 0.4 kilometer, that is 400 meter. Okay, this is the given data. Okay, they are asking you the time taken by the train to cross the bridge. It's very clear. You would like to go for this one. Suppose you have taken that bridge, it's going to be 400 meters. The train which is going to be approached here, yes, you have to consider this one. Oh, you can take that, it's very clear. Yes, it's going to be like that. If it has been crossed that, what is the total distance travelled? If it has been crossed that, this is going to be 200 meter. This is going to be the train. This is going to be the bridge. You have to take that. The total, it has been crossed that bridge, the total distance travelled by the train. Yes, total distance travelled by the train. Travelled by the train to cross the bridge. All right, that is going to be 200 plus 400 meter. All right, this is very clear. You can easily solve the problem. Measurement that's going to be taken as the 600 meters. The train has to travel that 600 meters to cross the bridge. It's very clear. It is going to be completely crossing that. Initially, it will enter here and it is going to cross. Yes, it's going to be 600 meters. Okay. Okay, what is the time taken by the train to cross the bridge? That is a question for you. All right. So, you have to get this one. All right. It is very easy for you to solve the problem. That T is equal to question mark. Time taken by the bridge to cross the. You know that the speed is equal to distance by train. Just you have to take that. Yeah, you have to take this one by train. It's very clear. Now, time is equal to, here you would like to get this one, T is equal to D by speed. Yeah, V is equal to D by T. That is the question. Now, it is easy for you to solve the problem. Yes, that is going to be T is equal to D by V, that is 600 by 15, that is meter per second. Just you have to take, this is going to be the 40, that is 40 seconds. It's very clear. Let's have the look into that matter. Yes, you have to take this problem very easily. You will get this one. 40 seconds, that is the correct answer for you. Just you have to go for that. All right, have the look into that problem solvation method and the way we can approach it. Sometimes they will ask you indifferently, the time taken by the train to cross the bridge is some x seconds, whatever it may be, which is having the speed and the length of the train also they have given. At that time you will know that no? Time that gives the distance or length of the bridge also. In what time does it crosses the bridge? Yes. Let's go for another one. Yeah, this is also one important problem for you. Dyne second is the unit of. Dyne second is the unit of. You have to confirm. Generally, you are going to get that dyne, which is used to represents the force. represents the force. The force. All right, it's very clear. Dyne is a derived unit for the force in CGS system that we can use. All right, it's very clear. So, dyne, you are going to know that this is going to be, yeah, dyne into second, that is equal to force into second. All right, it's very clear. We'd like to go for this one. So, easily you can take that force into time. Easily you can go for that force into time. All right. Now you can easily find out that expression, F is equal to, your aim is going to be, what does that dyne second represents or unit of? Yes. In this question we would like to solve the problem. All right. Now you are all going to have the look. That's going to be F is equal to ma, mass into acceleration, that is m into v minus u by t. It's very clear, right? So you can take that m into v minus u by t. This is the case, we can know that. And also you are having that t. You can cancel the term. It's very clear. It's very clear. If you are going to make it the cancellation, right? So that is equal to, you will get that answer, mv minus mu. That is change in momentum. You have to get that change in momentum. Okay, that is the unit for all right. Does it represent? What is the given question? You have to understood that dyne second is the unit of for momentum. Just you have, if you wants to get the momentum for momentum and also unit for that change in momentum and also unit for the momentum is same. It's very clear. Okay, what we are having the final result, that is going to be that change in momentum. If you wants to get that representation, you will get the unit is going to be momentum. It's very clear. If you wants to represent change or if you wants to represent the momentum, the unit is going to be same. It's very clear, right? Okay, so that we can take that dyne second is equal to, that is the unit for momentum. All right, it's very clear. If you wants to check the other options also, which is having the possibility, let's have a look. So force, no issue at all. Yeah. Power, if you are going to get that power is equal to, just you have to take that rate of doing work, that is going to be force into displacement by time. Okay, this is not at all going to be having. So even though we would like to discuss, that is very clear. While you are going to measure that power, it's going to be the rate of doing work. All right, it's very clear. So it's very clear. Momentum is going to be the correct answer, right? Right. Over the discussion, just have the look into that matter of the given problem. Okay, just you have to go for that and solve the problem. Okay students, just go for another question. Yes, it's very important, just you have to consider that question. Which of the following does not give the unit of energy? That's very clear. You have to go for that. From each and every option you will go for that verification, then only you will confirm that which is doesn't give the unit of energy. Please have the look. Right. Okay. Yeah. First of all, we would like to go for this one, watt second. Watt second. Just you have to take this one. Okay. All right. While you are talking about that, power, yeah, this is going to be that work done by time. It's very clear. Rate of doing work that gives the power. While you have taken that electrical appliances which can drive in the duration of the time, yeah, for their utility. So within the period of the time, if they have done the work, that is going to be equal to that energy also. It's very clear, just you have to confirm. All right. It's going to be taken in watt, it's going to be taken in time. So watt time into time, that is going to be equal to work done. Yeah, that is going to be energy. Just you have to take that. Work done is nothing but energy. Yes, you are going to get that. If you know that work done, that is equal to force into displacement. Very clear. All right. Okay, now let's go for that. Yeah, joule is a derived unit. 1 joule is equal to 1 Newton meter. That is force into displacement. Easily we will confirm that. All right, it's going to be energy. While you are going to confirm that, yes, work done is nothing but energy, no issue at all. Okay, if you have taken that kilowatt hour, time is in second, just you have to take that power. If you want to represent that power by means of kilowatt or watt, just you have to take. Now, kilowatt hour. Just you have to take that. You have to remove the. It's also very clear. That is also going to represent that energy. No issue at all. All right. Now you will go for that Newton meter. It's very clear. Newton meter. Yeah, what we have discussed about. 1 Newton meter is equal to joule. It's very clear. That is also joule. That is also represent the energy. All right, it's very clear. While you have taken that Pascal, just you have to take that Pascal meter. It doesn't give the energy, right? Just you have to take that. Yeah, Pascal meter. Does not give the unit of energy. Unit of energy. All right, it's very clear. So let's have a look into that matter. What they have given that watt second, kilowatt hour, Newton meter, Pascal meter. Okay, which of the following does not give the unit of energy? It's very clear. You would like to go for this one. All right. Now, what we have discussed about that, work done is equal to force into displacement. All right, work done by a body is going to be in the form of its potential energy. Yeah, work done is going to be its energy. All right, it's equal to energy. Yeah, very clear. Now, if you are going to take that power is equal to work done by time, rate of doing work is nothing but power. You have taken that watt power into time, just you have to take that time. It has been represented in seconds. While you have taken that seconds or in terms of that just you have to take. It's very clear, you can go for that, have the look into that matter. So easily you will confirm that it doesn't give the unit of energy, alright, okay. So in this way you can analyze the given options and confirm the final answer, alright. Yeah, sometimes they are going to give you the matching type questions, you have to answer the questions. So the dynamic temperature, while you are going to have that some base quantities, you can get that. Yeah, dynamic temperature is a supplementary quantity or fundamental quantity or derived quantity. It is very clear. We would like to go for this thing. Yes, you have to take that. That is very clear. Yes, you can take. Yeah, you are going to get that density. It depends on mass and volume. Depends on mass and volume. Yes, you have to take this one. This is very clear. Now you have to confirm volume also depend on length, breadth and height, LBH. It's very clear. So the dependency which is going to extended for that different physical quantities. Initially you have taken the density which is going to be dependent on mass and volume. You can take that mass is an independent, it's very clear. Mass, yeah, you have to take that independent, mass is independent. But while you are going to take that volume, it is dependent, it's very clear. Volume is equal to mass, just you have to take that. Very clear, you can take that. Just you have to confirm. If you have taken that arbitrary unit, just you can go for that, which is going to be having that regular body, its volume can be measured. Sometimes you will get that the volume occupied by that liquid, you have to take that, it's very clear. Yes, yeah. Finally, what you will conclude that matter, if you are going to express that dynamic temperature and density which are going to be dependent and independent, no? Supplementary quantity, fundamental quantity, and generally if you are going to take that fundamental quantities, they are going to be independent. Alright, you can take that now. Derived quantity, that is going to be dependent. Alright, it's very clear. Supplementary quantity, they are going to be having that after 1971 they have taken that arbitrary quantities which are going to describe that circular motion and motion in a plane and 3D motion, 2D motion. We have to get that to measure the angle, that is going to be the plane angle and solid angle, we have taken that. Yeah, we would like to get that plane angle and solid angle, it's very clear, we would like to go for this one. Alright, okay, from all these things just you can confirm, this is going to be taken as, yeah, the thermodynamic temperature, it's going to be the derived, just you have to density, it's going to be derived, and mass is going to be the fundamental, volume is going to be the derived quantity. Alright, you can give the answer very easily, right. Thank you very much, have a nice day, let's meet in the another session.